All right, everyone in the back can hear me? I think my mic's on. Okay, cool. This is GraphQL. My name is Dustin. This talk was originally titled GraphQL, the good parts, and that's just me being lazy and uncreative. Really, it's GraphQL, most of the parts. So really what I want to do is I'll start with an introduction to some of the foundational concepts of GraphQL, the kind of bits and pieces that make GraphQL so enticing. And from this foundational perspective, we'll construct the argument for why GraphQL matters, why GraphQL is sweet, et cetera, et cetera. We'll kind of segue into integration pieces. So given this cool concept of GraphQL, how do we integrate it with our existing APIs, our existing databases, our existing REST backend, you name it. We'll do some brief stuff on some integration with client-side libraries using things like Apollo. And then at the end, time permitting, which I hope we have, I'll do some live coding. God save me, and I'll also have a few demos at the end too. So, with that said, who am I? My name is Dustin. I am known for weird pictures and meetups. That was in this listing, and every time I see it, it makes me laugh. So when I'm not looking weird in meetup photos, I'm a front-end developer. I work for a company called Object Partners. We just got voted #1 of our size in Omaha, so that's kind of cool. So if you're interested in hearing more about that, about me, about JavaScript, you name it, come talk to me after at this Beer.js. I will certainly be there having a beer. So yeah, that's that. And so I'll start this talk with 2 caveats. Number 1, Facebook-driven development is a thing. There's React, there's React Native, there's Jest, and then there's, of course, GraphQL. And a lot of people, aren't super sold on this. There's a lot of hype behind a lot of these. You might like your current stack, be it Ember, Angular, you name it, and you don't have to use all this hot, trendy new things. I'd like to think that GraphQL is a little bit different. Not that React and React Native, etc., aren't great, but if you're of the camp that doesn't want to follow these hype, these trends, I think GraphQL is more than this. I think GraphQL is kind of transformational and kind of like a new shift for how we can design APIs and how we can design backends. Stomach that for this talk. Hopefully I'll persuade you that it's not just FDD and there's some actual validity to this GraphQL stuff. Second caveat, is it a REST killer? I quoted REST killer in my description, which is a quote of someone else. I don't think that myself. So, no, it is not. And also chill, it's a quote. I don't think that, and this talk is not intended at all to say that GraphQL is ending REST. I think they're both great technologies, and as some of these slides will show, I think that GraphQL enhances REST. So this talk is not about how GraphQL is killing REST. It's really centered on the idea of, but maybe. So maybe it's not killing REST, but maybe introducing GraphQL into your stack can do some really solid things and can lead to some really good benefits. Things like less payloads sent to your client, a cleaner API, cleaner documentation, all while, if you want to, utilizing your existing RESTful backend. So if this talk were accurately titled, it would be GraphQL, most of the stuff, REST is not dead, but maybe we can do better. And so this is what this talk is about. So to begin describing GraphQL, we need to talk about what it actually is. So these are the foundational pieces, the kind of, like I said earlier, bits that make GraphQL so enticing. So the very first thing that GraphQL is, it's a query language. And so first, let's talk about our existing data structure. I'm using TypeScript here. Is that font readable in the back, hopefully? Sweet, that's great. So this is TypeScript. We're defining that our RESTful API will return a user in some fashion, and a user is composed of a name, which is a string, an age, which is a number, a title, which is a string, and a department, which is also a string. So just kind of keep this as a mental model for what a user is when we're talking about some of the next stuff. So this is our first taste of GraphQL. On the top left, we have our GraphQL query. And so this is basically, kind of think of it like a function that's injected with query variables. And then these query variables are then passed to our actual GraphQL query. So this is the actual query. This is basically a function we're calling to kind of make this dynamic and then pass query variables on demand. And so what GraphQL really is, or at least the query language, it basically looks kind of like JSON with functions. These are called resolvers. We'll get into that in a little bit. And basically, they take arguments or options, and you specify the type. So I'm saying here that I want to get a user by an ID. ID is of type integer, a number, and I will make some requests. I'll resolve this data somehow, and I'll resolve a user type. And so like we saw earlier, a user was defined of age, name, title, description, but for this particular view, I might not need age, name, title, whatever the other category was. And I might only need 3 of them. And so I'm just pulling exactly what I need, and when I play this query back, you can see that the structure you get, the result is JSON, and it directly ties to the structure that we requested. So we kind of used this JSON-like query syntax and got back JSON. So it's pretty clear, user.age maps directly to age. User.name maps to user.name on the left. And that's kind of one of the big benefits of GraphQL, is this query language where you can pluck only what you need. You don't need to pull down the entire user object, even if you're only using 1 or 2 fields. And then down the road, you can change it. You know, if I don't want that age and that title, I can just still pluck this name field. Here I'm using an alias, so in GraphQL, that's denoted with this little colon. So I'm basically saying I want the name as specified in user, but I want it in my JSON as username. So we make this request, and we get back our expected structure and shape. And so I think many of you are probably jumping the gun. Well, this is not really transformative. I could do this in REST with some type of like CSV-like structure where I hit a RESTful resource, I specify my ID I want from my user, and then I just pull the name, age, and title, or just the name fields. And I agree, you know, that's actually not that bad. If this is all that GraphQL did, this kind of single-dimensional, one-layer nested data, it's not really replacing REST. It's not really that much better. We could certainly go with that structure, and I'd be pretty okay with that. But wait, you know, there's more to this. So let's take a look at another query. So let's say down the road that our view needs to also show a manager, and we want the same type of fields that we get from a user on this manager. So a manager is a user, just a special kind of class, and they have the same properties on user. So we are requesting age, name, and title, and similarly, we're also requesting our kind of nested manager. So I'm getting this user's manager, and I'm pulling age, name, and title from my manager as well. I can play this query back, and of course, I get my expected shape. I get Tim Timothy, the boss man. He's 100 somehow. So yeah, this is a kind of like a deeply nested query. And so I don't really know how I would do this with REST. I'm sure someone's really excited right now to tell me about some library that they have in Java or Groovy or backend stuff that I'm not as good at. But I think GraphQL query language makes this really simple, and it kind of directly ties into some of the next things we'll talk about, using resolvers and kind of doing this in a really clean, clear way, getting a lot of benefits along the way. So queries are the R in CRUD. So let's talk about the CUD, the C-U-D. In GraphQL, the CUD is a mutation. And so a mutation is pretty similar to a query. So what it'll look like is it is a name of a mutation. A mutation can accept optional arguments, and then a mutation returns optionally some structure. And so for instance, if I want to create a review, I'm going to actually, send like a post. I'm going to create this review object. The arguments this mutation accepts are an episode, which is a string, a review, which is a nested JSON structure. So a review contains stars, which is a number, commentary, which is a string. We run this, and we get back our expected shape. So data.createReview, and we get back stars and commentary. It's not super useful to get back exactly what you passed in. So what I've seen a lot here is that you get something new that was kind of created for you. In our examples at the end, you get back an ID field. So something that's kind of generated on the server that you want to pull back and use in your UI somehow. And so obviously mutation can create a resource, it can update a resource, and it can delete a resource, depending on what you use in a resolver, which we'll talk about in a second. Yeah? Do the slide again? Okay, so yeah, so I think we'll get more into this in the live coding. But yeah, so a A mutation is basically, think of it like a function call. This function call is triggering some update to a database, to your RESTful backend. It can be kind of anything. It just needs to return something that has the property stars and commentary. So you can think of a resolver, which we'll get to. Good? Okay. So GraphQL is also a type system. So I know what you're thinking, oh man, another type system, there's Flow and there's TypeScript, and now I need to know GraphQL type system. And I sort of empathize. It is kind of slightly weird that it's just slightly different. It's kind of looks like TypeScript a little bit. So here we're defining our user, which we saw earlier, a similar variant. We're defining a number of fields and a number of types. So a user is composed of basically JSON that looks like ID, which is a special GraphQL-ism called ID, name, which is a string, age an int, title a string, and then manager, which is a user. And you'll note here this exclamation point. So this exclamation point means non-nullable. Basically it means that when I return something that is of type user, it has to have all of these fields, and user is nullable. So when I make a query or a mutation that returns a user, I might not get back a manager. Everything else I always expected to return given something that returns a user.
Are IDs required?
No, but IDs work really well with like caching. But I don't think you have to have an ID at all. But it does help things, especially when you get into things like Apollo. It helps caching a lot better. At least that's been my experience. GraphQL is a schema, and so a schema is basically a composition of a number of types, basically your data model. So if it's a RESTful backend, you might have Swagger or something, and basically you want to encapsulate that with the GraphQL schema. And so what a schema does is it kind of takes these types and it wires it up so that GraphQL can then expose this API. So here we have our previous user, and now we see our first taste of a GraphQL query. So it's just like a user, it's a type. And again, this kind of looks like a function call, because that's really what it'll be doing when we get to the next section on resolvers. This function call takes arguments. And so I'm calling this argument limit. Limit is of type int, and it'll always return an array, which is non-nullable, of type users. So basically this means that when I query for users, I need to send a limit from GraphQL, and it'll return 0 or more users. It'll always return an array. And then we wire it all up with this schema. And so schema takes queries and mutations, so query of type query. In the live examples at the end, I'll show a mutation. But this is an example of a GraphQL schema. I will note here, and I'll explain it in more depth in a second, this is using something called GraphQL Tools, which is a library from Apollo that I think makes stitching this up and wiring this up a little bit easier. But there are other ways to do it than writing it this way. There's like a more JavaScript-y API that the actual GraphQL JS module exposes, but I think this is a little bit cleaner. So it's a means to resolve data. So up to this point, we've kind of said, well, here is what our API is, but we haven't really injected this API with data. We haven't made this API live. And so how that works in GraphQL is via a concept of resolvers. So this is slightly challenging to explain, but basically every key in this object at the root level, at the first level, refers to a type. So query is referring to our query in the previous example. Query is here. And so the fields inside are children of that main type, or or in this case, the query. So to resolve users, the kind of path is a JavaScript object query with a subkey of users. I'll talk on the next slide about what these function arguments are, these root args, etc. But for now, basically each one of these resolvers needs to return a promise that resolves to data, or it needs to return that data directly. So if you didn't have an API and you just wanted to mock it out, you could just as easily return like an array of user objects here without actually making a request to your server. So it's a really easy way to mock stuff out. Next, so we have that user type. And when we request a manager, GraphQL will call this manager function, and it'll make a separate request. So basically, because a manager is a separate kind of user, it's not exposed when I query for users. I need to give GraphQL a hint that when I see this manager field, how do I actually resolve this to a user? And so the API is basically, same as any other resolver, we're returning a function, or we're returning a promise, or some kind of like simple value that maps to what we're requesting. So let's get into these arguments and what each of them mean. All right, so resolvers in depth. So query and mutation are kind of special. The first argument is basically the current value of what you're resolving. And so because query doesn't really, the value of the parent. And so because query doesn't really have anything special, the root here is basically undefined. It's not super useful. Args is basically an object of arguments that I've sent to this GraphQL query. So earlier, I think I showed limit. And so args will be a JavaScript object with limit defined as like a number. Context, I want to mention, I don't use it in any of my examples, but context is how you share kind of data between any resolver. So context is a great use case for things like authentication, OAuth, however you want to do that kind of stuff. Basically anything that you think makes sense to share between each of these resolvers, you'd want to put that in context, and it would be exposed to these resolvers under that third argument. So next, now our first argument is a little more interesting. When we resolve a user on this separate field, we already have a user at this point. So it'll basically resolve a user, and then it'll go and get things that it doesn't have. So for instance, to resolve this user manager, we'll call this for every user that we receive, we'll call this manager API if the GraphQL query specified that this manager be included. And so the first argument is actually the value in JSON of the user I requested. So this user will have a user.id, user.name, user.title, whatever I need to actually make that separate request. So this is actually a really, really just awesome way to reduce round-robin requests. So if I want a manager always when I request a user, this is how you can do that in GraphQL via this concept of resolvers. And so wiring it all up is pretty easy. Like I said, we're using GraphQL tools, which is a library from Apollo, open source. Typedefs is basically your schema as a string. It's the previous example of what we were showing. Resolvers is that JavaScript object, each key, a function that resolves to a promise or something that matches the shape of what I'm of the type. And then our schema, which we can use in something like Express GraphQL, something that we can actually use this schema, is created with this function make executable schema. So I'll show this in a little bit more depth during the live coding session. So hopefully not too overwhelming. I think it's kind of cool because basically we just resolved two RESTful endpoints doing something that was normally a little bit more challenging in like 10 minutes of explaining it. And so this kind of, I think, shows the power of GraphQL, and in particular resolvers are a key aspect of understanding how GraphQL can be so transformative. And if I haven't explained this well enough, so let's basically say that when I'm requesting a user, and I want to display it on this view. If I were to use the traditional REST approach, I would need to display this user, kick off another request, and then I would get the manager at some point in the future. With this approach, with GraphQL, I can request exactly what I need for this specific view and get both with one request. And if my needs change down the road and I no longer need a manager, I don't need to modify my REST code or my backend code. I can just do so with my GraphQL query. So, this is Nebraska.js, so I'm definitely going to have a JavaScript focus, but GraphQL is backend agnostic. So pretty much bring your own backend. .NET, Erlang, Go, Groovy, Java, etc., etc. If you're not a JavaScript shop, if you are a Groovy shop and your backend is written in Groovy, there are reference implementations that let you use GraphQL on your server in each of these languages and probably more that aren't even on this slide. So basically, you don't have to totally dive into the Node.js ecosystem. There are implementations in other languages. So if you're, like I said, if your team is, insert X language here, don't rule out GraphQL because you think it's just Node or JavaScript based. So I've I think, explained some of the problems it solves. Querying is a subset of data, getting the user data from multiple endpoints, but in one request without hitting X, Y, and Z endpoints. And then also just a pretty clean API. It also solves other problems. So John, creator of jQuery, says, ha ha ha, GraphQL is totally, so you decided to use a NoSQL database and now you want reasonable queries back. Here's GraphQL. And so basically the heart of, I think, the appeal of GraphQL, especially to me as a front-end developer, is basically here is a super slick, intuitive way that I can make this data understandable and really easy to query against. So regardless of whatever insert hot backend technique of the day, like Mongo or DynamoDB or insert whatever here, you can put GraphQL as kind of a front end to that data and make it more easily consumable by your developers or by your users. It's also documentation. So that GraphQL schema that we were talking about earlier is actually really easy to be wired up to a tool called GraphQL or GraphQL. I don't really know. It's one or the other. But basically, this is a React app that you can get really easily with some of the middlewares. The one I used here is for Express. Literally, I set true on a JavaScript object, and I get this for free. And I basically get a playground where I can hit my actual GraphQL API, and on the left, you get like an auto-completing IDE. I'll show this more in depth at the end. And then you can actually hit the API. And then on the right, you have your schema. So when I request posts, I know that post accepts start, limit, and then return a post. Like I get a really good understanding of my data contract, and I can also call it directly. So of course, anyone familiar with like Swagger or anything like that has seen something kind of like this. But I didn't write any code besides that type to get this to work. This just worked out of the box. I think that's pretty sweet. All right, so I'm browsing Twitter the other day, and oh my God, Kanye tweeted something. What is this? So I click it, and I see that it has 28,000 retweets and 121,000 likes, and person X, Y, and Z liked it, and that shows their avatars. And then I want to go and read the comments, and so I load all these comments. And so basically, I don't think Twitter's API actually works this way. This is just for purposes of demonstration. So to get that first timeline, I can call this API tweets, and it'll return basically an array of all my tweets without all of the data I requested. Basically, just the minimal subset of what I need for my current view. Next, to get more detail, to get those user avatars and stuff like that, I make a request for this particular tweet resource. And then finally, to get the whole conversation, I make a third request. And so what we really introduced is the concept of like waterfall requests. We make one initial request, and then to get more detail drilled down, we make separate other requests. And for anyone who cares about page speed and performance and all that kind of stuff, this is not great. Waterfall requests make the client harder to kind of understand when you're actually writing it, and they of course make performance suffer. So GraphQL can resolve each of these as requested and kind of avoid some of this waterfall, giving the client just the minimum subset of data it needs to render this particular page. So I have an example. This is a 100% made up API, but pretend it's Twitter. And timeline is basically going to return an array of tweets. A tweet has an ID, a tweet has a body, a tweet has number of likes, number of retweets, and to kind of like hydrate and to give my page kind of like a speedy, performant feel, I can get the conversation for each of these tweets. So I'm describing the first 20. Really, that's probably unrealistic. I probably want like 4 or 5 or something. And then I can deeply get this conversation ID, this conversation body, what the content of this is, likes, retweets. I forgot authors, but authors would go there too. And so basically we can call this, we get back our array of tweets, and we get back the minimum subset of data we need to render this particular page, while also doing so performantly. And if we click on a tweet, we can then use our first 5, 10 conversations or whatever, and then get more as they scroll down the page. So this makes GraphQL reduce this waterfall requests and render this page performantly using exactly what I need to hydrate this page. So let's come back to this question. Is it a REST killer? I know I said I wasn't going to say it is, so I won't. No, no, I do not think GraphQL is a REST killer. I think it's kind of contradictory to say that something is killing something when it makes it better. In my opinion, putting a GraphQL layer in front of your RESTful API is one of the best ways you can make your API better documented, more easily queryable, and get some of the benefits we talked about, like better client-side speed, easier queries, easier understanding, all from the client. So no, I do think that GraphQL is novel. So basically, if you're a REST person, I hope you don't think that GraphQL is stealing your jobs, because it's not at all. So let's talk about integration. How do we actually integrate? I've kind of showed this to some extent. The example I gave was like a RESTful backend. And so basically it's going to be from that context how I kind of construct this integration argument. So number one advice is layer the GraphQL API in front of your existing REST APIs. So if you already have a great REST API that you really like, works really well, you don't need to go whole hog and migrate over to GraphQL. You can do it by just putting a GraphQL layer and using the resolvers approach that I showed earlier. And I think this will be a lot better for reasons like you can keep your business logic intact. I've seen some pretty nasty controller functions that are doing X, Y, Z, and the other thing. You don't need to refactor those to use GraphQL. You can keep those as is. They're working somehow. Hopefully they're tested. But basically by using this approach of just GraphQL layer in front, you can do this more gradually. And my other advice is to adopt GraphQL gradually. You don't need to have a month or 2 months or whatever to say, hey, we're going to expose a GraphQL API, and it's going to do everything our REST API does. It's going to hit every single RESTful endpoint. That's not at all what you have to do. I mean, you can expose just 1, 2, or 3 APIs, make your backend service, which could be like monolithic or whatever, make it more easily queryable, more easily consumable, while getting some of the benefits of GraphQL that I've talked about. So there are tools that I think make this a little bit easier. Apollo is a really big one. Apollo has a number of open source libraries. That GraphQL tools library I was referring to is from Apollo. It's open source. They also have kind of like a service offering. And so the one I've seen that seems kind of enticing is they have a service offering that'll kind of profile your GraphQL queries. It'll do really slick caching of your existing APIs, and it'll give you like really good logging as well. So Apollo is like a really big hitter in this GraphQL space. GraphQL is another big hitter. I'm not as familiar with GraphQL, so if anyone after has used GraphQL and wants to say yay or nay, let me know. But basically GraphQL is doing similar things to Apollo in this space. They're kind of offering GraphQL as a service. So given your existing API, your existing backend, we can wire this up. We'll give you kind of like a serverless GraphQL API, and you can pretty quickly hit the ground running using GraphQL. So definitely, if you're interested in this space, check out both of these tools and their offerings. They're pretty great. So basically my advice, let's say you have an API right now, and you have a /user and a /user ID. What I would do is at the same URL, or at least like a similar URL, expose a /GraphQL endpoint that is your GraphQL API, and begin by just migrating 2 of your kind of like simpler ones. 2 of the ones that are easily understood, that have a good data model between what you call and what you get, and then start integrating GraphQL using this approach. Using the gradual approach, just putting a layer in front of your existing RESTful backend. So this talk, I did want to talk a little bit about client-side integration. I wanted it to be mostly backend server-side focused, but some of the big benefits we're talking about are in the client-side integration. So I think it's at least worth mentioning some of the client-side libraries and techniques. First is Apollo. So just like in the backend integration, Apollo has a number of really, really great client-side offerings. Their big one is called Apollo Client. And they also have a number of kind of like wrappers of Apollo Client that lets you work with Apollo, with Vue, with React, with Angular. I think I even saw Polymer. I'm sure there's a framework agnostic solution as well. And basically, it lets you hit the ground running pretty quick and easily, wrapping up this GraphQL API and giving you some other niceties. So let's take a look at Apollo Boost. So Apollo Boost came out, I don't know, in the last 6 months at least, probably even sooner than that. And it's a React library. So hopefully at least some people in here are interested in React. And basically what it kind of advertises as is like a really simple, like 10-15 minute way you can begin integrating GraphQL into your client. And so it exposes a number of like really helpful things like React components, as well as this import GQL. So GQL is from GraphQL tag, another library. And basically what it does is you can write your GraphQL queries as a string, and it'll convert it to an abstract syntax tree. And this tree can be passed to this React component. So basically this is saying, query movies, give me the movie I asked for. I don't want to get too React specific here, but basically this is a function it's invoking at various kind of like stages in the life cycle. So when it's loading, you can display a loading screen. When it's in an error state, you can display an error state. And then finally, when it actually does resolve the data, hopefully all things going well, you can return the actual movie based on that GraphQL query. So GraphQL, another similar story. I have not used it, but I know people really like it, and they offer some client-side options in this space. Noticing a trend here. So yeah, so like I said, those are the two big offerings in both kind of back-end and client-side GraphQL, as well as some of the stuff that Facebook puts out, like their GraphQL breakfast implementation. So if you're interested in this space, be it from a front-end or back-end perspective, check out Apollo, check out GraphQL. They can both do some really nice things for your API. Of course, people get kind of like library phobic, and I don't need this library. So you can also use fetch, just the vanilla fetch client. GraphQL, the way it actually works is it exposes a post endpoint. So you can send headers, and then you can send your query as a JSON body, and this will work just the same as the previous example, but you're not getting the niceties of, well, how do I handle an error state? How do I handle data state? How do I handle loading state? You're getting all that for free, and it's kind of wiring that up for you. Of course, if your API is authenticated, it's going to get harder and harder to kind of maintain this. And so basically, I would urge you to consider one of the libraries, but if you're the type who wants to roll your own, fetch works just fine. Urkel is from Formidable. If you are, yeah, that's a great picture. If you're in the React space, Urkel kind of advertises itself as like Apollo client, but strictly for like React. So it's React optimized, supposed to get you up and running really quickly, and offers some like React components that do similar things to Apollo Boost. Woo! So demos. That is me right now, Jordan Peele. So what I'm going to do is I did a couple things. So I wrote a REST endpoint with Express and then hosted it with Now, and I'll go into some detail. And basically what I want to do is kind of what this whole talk has been about. I want to take this REST API and I want to enhance it with GraphQL. So I have a separate GraphQL API that I have like a really basic structure around, and we can begin by integrating queries and mutations. And then finally, what am I doing on time? Oh, I have plenty of time. Okay. I'll also show the speaker signup, which, so as Nick was referring to earlier, we have Nebraska.js has a GitHub repo where you can open up an issue and you can kind of submit a proposal for the next Nebraska.js talk. It could be for yourself, it could be for someone else, etc. I don't think a lot of people know about it, so I wanted to kind of put a UI around it, and you can do things like add a proposal, add reactions, etc., etc. So first, though, let's start with the live coding. Oops. So this is just the repo. This is a simple Express app, nothing major here. It's a simple CRUD API. I can get posts, I can add a post, I can delete a post, I can update a post, etc., etc. We have a kind of secondary layer, kind of analogous to the user manager approach of, by default, we don't get comments with the post. So it would be nice when we request a post to not round robin and to get those comments along for the ride when we want them. So yeah, all this open source, obviously, so come take a look at this after if you're interested. But we can actually get started. How's that font size? Good? Okay. So I have this GraphQL backend. This GraphQL backend is just an Express node app, and it's using a couple libraries. It's using Express. It's using Express GraphQL, which is a middleware that lets us give this schema we're going to be creating, and kind of create a GraphQL endpoint. It also, for free, lets us use that GraphQL graphical kind of like UI, and it does this with 2 lines of code. So this is kind of cool. Basically, when we go to our API, wherever it's hosted, we can do /GraphQL, and we'll see the graphical UI. So we also have the schema, and here I'm using GraphQL tools. So the first thing I want to do is I want to install these 2 things. How's the font on that? I'm going to go a little bigger. All right, so I like to use Yarn, but you can just as easily install these dependencies with npm. So I'm going to install both of these. All right, now we're getting closer to going. So this schema is just an ES2015 template literal. It's a string with multi-lines. And so everything I can put in here was stuff we talked about. So I can have a post. And so basically, what you need to ask yourself here is, what is a post? What is insert X in my existing RESTful backend? And so like I said, most people put kind of like a Swagger endpoint. I didn't do that. I don't really need to make this super enterprisey. But so basically, I use this library called yup. And when I update or add a post, I call this basically validator function. And here is a pretty good indication of what a post is. It's a title, it's an author, it's a published date, and then it's a body. ID is optional because when you're creating a post, you don't know the ID is created for you. So I can copy this over, make these all strings to begin with. Each of them is non-nullable because a post is defined of these minimum subsets of attributes. ID is an ID. They know the GraphQL-ism. And so now we have our first type. So to actually use this, we need to create a query. So again, looks kind of similar to the previous samples I showed. Type query, and then every kind of like, think of like key value is kind of like a function. It's a resolver that resolves to something. So to get a post, I'm going to start with a kind of easier approach. I'm just going to get a single post. And to get a post, what I need is an ID. So I'm requesting an ID, and a post, this query, this resolver will always return something of post, but that's not actually true. If I query for ABCD and that does not exist in my database, I'm going to get a null post. So I need to make this nullable. Finally, we have the schema. And so the schema is composed of a type of query, and if needed, a type of mutation. So I can give it this. I can get rid of that to do, and let's see our first GraphQL API. Sweet, it worked. So it's hosted at localhost 4000, doesn't matter. All right, so this is GraphQL. And so it's basically like an IDE kind of in the browser. So I can query for a post, I can give it an ID, and you can see it's auto-completing for me. So ID is whatever, 1, 2, 3, 4. And then when I get a post, when I query for a post, I know I have a post, so I can request my what I want when I want to display this post. So I want to display the author, I want to display the body, I'll grab the ID, and then the published date. So I can run this, I'll get back null. And that makes perfect sense because I haven't wired it up yet. I've only exposed the schema, I haven't resolved any of these fields to much of anything. So let's close this, let's go back, and let's start wiring up these resolvers. So like I said earlier, basically any type is a top-level key for those resolvers. So to get a post, I want to wire this up as query, top-level query, and then post. And so like I said, each resolver is a function. And so this needs to take this root, don't need it. Args, I do need. So this args will be an object with an ID of whatever type, of type ID. And then if I wanted to have this be authenticated or whatever, I would probably use this third argument, context, to send that along for the ride to my RESTful endpoint. So I am using a few API or a few libraries here. Axios, kind of like Fetch, just an HTTP client for Node. It's a little, it does things a little more automatically for me than Fetch, so I like it. Config is a library where I can just externalize in JSON these different config files. So this is actually the API that I'm hitting. And then query string just basically says, given an object, convert this to a query string parameter. So first thing we want is we have these args. We have this ID. So this is an object that has basically this in it. I'm using destructuring here, but I don't have to. So I can just go this way. If I want to get the query string parameters, I need to call query string dot stringify args. And so basically what this will do, I jumped the gun, that is for the next section. I want a URL. So the URL is just going to be base URL, right, slash posts slash args.id, so a typical RESTful request. And every resolver needs to return a promise or the actual value I'm requesting. So I can do Axios URL, and then Axios unwraps this promise for me, so I can just do response.data. So now we can run this again, and let's see what we get here. Whoops, sorry about that. Null. Wait, I don't think it resolved yet. Okay, so request failed with status code 409. That makes sense. I'm not querying for an actual post yet. So posts, this is going to get all the posts so that I can then use this ID. And so here you can see what a post is: title, author, ID, published, body. You can use this. And now we see our REST backend resolved with the actual data when I request this post. Obviously, I can get rid of any single thing here, and it'll still resolve to the shape of what I'm requesting. So my query drives my output. So one of the appeals of what I was talking about is kind of resolving those round-robin requests. So when I want a post, I don't necessarily want to make a second HTTP request to get that list of comments. And so there's a RESTful API that I exposed in my REST backend that basically returns comments for a post. So to actually to kind of give a hint to GraphQL of what a comment is, I need to use a comment. I got lazy in my REST backend, and so I did not add an API to add comments. So I need to look at my database, which is just JSON, and I can get a pretty good idea of what everything is. So again, same type of thing here, making these all non-nullable. I have a unique ID for each of these, so I'll use the GraphQL ID type. And now, when I request a post, I also want to optionally request all the comments for this post. So I can wire this up, and so basically I'm saying this is a resolver, and this resolver might have optional arguments. So for comments, I might want to limit to say the first 5 comments. I also might want to start at this number. So for instance, if I hydrate the page with the first 5 comments, when I want to load the rest, I don't want to start at 0 and request 10. I want to start at 5 and request the next 5. So this is a way I can do that. Both of these are nullable, which means I can call this without these arguments, and it'll basically give me the entire contents of my comments API. And so comments returns an array, non-nullable, of type comment. So again, it needs to return either an empty array or an array that if it does have contents, each of which is a comment. So this is the kind of slightly more complicated part I was talking about earlier. So basically, each type, again, is a key. So this is post. And I want to resolve this comments field. So comments, the very first argument, when GraphQL resolves these, it resolves the kind of base level thing first. So at the time this resolver function is run, I already have my post. So the very first argument is post. The next is this kind of optional args. So if args was supplied, if arguments were supplied to this function, it would be limit of type number and or start of type number of type int. Don't need to use context here. Here's where I was stringifying earlier. So params qs.stringify args. So basically, this will create the structure if args is defined, like limit equals 10 and start equals 10. So I can pass that as a query string directly onto my RESTful backend. Right? And so because I have a post at the time this is resolved, I can do Axios. I need to do a URL. So the path to this is my base URL /post/post.id and then /comments. Of course, I want to bring my friends params along for the ride so that I actually get back what I expect, the number of things I expect, and we can make this request. This is a promise, and the response is on response.data. This API returns a JSON object. The only key in it is comments, which is an array. So to get back the actual shape that GraphQL expects, I just need to call this comments. I can save this. I can rerun. All right. So if I query this, I could have probably logged. This is not calling comments at all. There's no second request. It's not even resolving that because I haven't requested it. The first time I do, oops. All right, I'm using the autocomplete. Let's say, to begin with, I just want to get everything. A comment has an ID, it has a published, it has an author, it has a body, and I want all of those things. I can run this, and I get back my entire array of comments. This is just one GraphQL query, no client-side logic to fetch this, then the other thing. It's doing it and handling it at the back-end level for me, conditionally when I ask for it. So this right now is kind of, I'm not passing any arguments because both of those arguments were optional. Let's say I only want one comment. Works just fine. I get back just my one comment. Of course, I can bump this up and I get back multiple. So that's kind of how you begin wiring up queries. I figured I can show a mutation too. It's pretty simple. So a mutation is just like query. It's a root level type. Call it whatever you want, but I'm going to call it mutation. And it's going to be a function that creates a post. And so a post in this mutation is slightly different than a post, a type of post. I basically don't know the ID when I add a post. So basically, I can call this input, post input. Input basically is something that is passed to a mutation. And I want everything besides ID, and the ID will be created for me. Right? So that is the mutation. It takes input of post input, and it'll always return a non-nullable post. I need to add this as a mutation, and I need to actually create the resolver. So root level mutation is called create post. Mutations and queries, because they're kind of like already at the base level, don't really have anything provided at that first argument. It does have the second argument is actually going to be input. So I want to pluck input off of that JavaScript object. I can start setting up my URL. So it's going to be base URL posts. I'm returning a promise, axios.post URL, then response.data. Second argument to axios.post is basically the JavaScript object, the kind of JSON you're sending onto the server. So that is input. And let's try this out. So the syntax is going to change a little bit. It's going to be a mutation. I'm going to be creating a post. I can already see the IDs handling things for me. And a post input is composed of title, author, published, body. So title, hello from Nebraska, typing is hard. Author is me. The published is just today, so published is 05/01/2018, and then the body is GraphQL is sweet, in my opinion. And I think I did. When I run this, I get back, oh, I just needed selections. I get back this ID. I only requested ID, I actually requested nothing, it autofilled that for me. But basically when I create a post, I get back a post. So now I can go back to this, I can query based on this post I just created. ID, it'll be the ID I pass in. Body, author, title, published. And I can pull this back. This, like I said, is using a RESTful backend, so my business logic stays intact. You'll note I sent like a JavaScript date, kind of, and this gave me back an ISO string, so it handles that serialization layer for me. Obviously, super simple example. You know, you could be touching 35 different systems and doing all this stuff when you create a mutation. So yeah, I kept the business logic intact, and I exposed a GraphQL API with queries and mutations. So that was that demo. I actually kind of have another one. So like I said, I think we have an awesome community here, and I hope people are as interested and passionate about it as I am. So I wanted to create something to kind of give back. So basically, this is a site. It's currently hosted on Netlify. Maybe someday, if people like it, we can get an actual root level domain in front of it. So basically, it's speakersignup.netlify.com. This is using GitHub's GraphQL API and a tool called Gatsby. So what's kind of cool is that I can log out, I can turn off, oops, go away. I can turn off JavaScript, and this page still works. It's statically generated React code, so anything, you know, without JavaScript, I can't actually do much. It's kind of like read-only mode, but it's still kind of cool. I can enable JavaScript, and so I'm not currently logged in. If I want to log in, basically what I went with is you kind of do something that requires a login. So if I'm really passionate about TypeScript, I'm going to add this ta-da emoji. Adding a reaction requires logging in, log in, sure. Okay, so normally there'd be a login screen. I've already logged in before, so that, you know, didn't show up. But so now I'm logged in, and so now basically what I have is I have a application that by default has these posts. And then from this point, I can then hydrate with GraphQL. So I'm using Apollo Client and actually Apollo Boost, and I can add reactions. I love TypeScript. No one gave my reason, post, and upgrade, so downvote. Observables, fan, love them, you know, etc., etc. GraphQL, I like it, I think. Heart, maybe I don't like it. Maybe, you know, whatever, etc., etc. So obviously I can get rid of all of these and they go away. It works just like GitHub. You can also check out previous proposals. You can see my test post, please ignore. We can upvote that one, etc. I think Web Components with Stencil was previously given, so that's a closed proposal. If I want to add one, test post, please ignore again. You can use emojis here. They'll show up in the other view. 100, wave, okay, hand, yada, yada, yada. We can send this. This is actually not using GraphQL. So GitHub is kind of using my approach of adopt things gradually. So for some reason, there's no mutation for creating an issue. There's a mutation for adding a reaction, because that's important. But I can't actually, so this is just using fetch to hit GitHub's old version of their API. I can send this, we got it, thanks. go back, test post, please ignore again, emojis, okay, hand is not an emoji, I guess, yada yada. Obviously, we can go to this repo, we can see it, I can add a reaction, refresh, there it is. So it all works out, which is kind of cool. So yeah, come check this page out. Maybe Nebraska.js can tweet it out if it's worthwhile. I can show some of the code. I think we have like 5 minutes or so. I don't know if people are interested in seeing the client-side code. Yeah? No? Okay, I'm going to show it. So this is, like I said, a Gatsby application. Gatsby is pretty awesome. It's a static site generator where you can write your routes, each component, each view in React. And I'm using Apollo to kind of hydrate this base client. So I have to set up a number of things. This Apollo client is the main way I communicate with GitHub's API. It doesn't really do anything until I authenticate, and then it uses your authentication token you get back from GitHub to set on this Apollo client. So GitHub it has a GraphQL API, and it's using that context argument that I was referring to earlier. So it's bringing on my authorization headers along for the ride. Code itself, so GitHub has a really good GraphQL Explorer. So basically you get kind of like a GraphQL interface where you can actually query stuff. That's how I wrote all of this. So I have this GraphQL folder. This is the query that's generating pretty much all of this. This view, this open proposals and closed proposals, is generated with this GraphQL query. So my query is called get all issues. This requires an owner, a name. The actual query on GitHub's API is called repository, and a repository basically has a number of fields. I'm only caring about issues. So I get the last 50, I order by so-and-so, and then I'm getting all of these. I'm only getting the first 10 reactions, so if we had 20 reactions, you're only going to see 10 of them, sorry. And yeah, this is how that works. Mutations, it's a little bit uglier. So this is just a dynamic, it's a function, it's an arrow function. So its mutation type is either add or remove. So mutation add reaction, mutation remove reaction, and it's calling the necessary GitHub GraphQL API. So yeah, that is the demos, and all of these are available. This slide deck is hosted at graphql.dustinschau.com. Check out some of these links. I'll tweet stuff out after this. And thank you for listening. Really appreciate it, everyone coming out on this crappy day. Any questions?
How do I sign someone else up to speak?
You could, so you would just submit a proposal. You would say, this is for so-and-so. And
can't make it look like Matt signed up?
No, so it uses the GitHub API. So whatever your user you authenticate as is what the issue will be opened up as. Yeah, and that's another point. Like, you don't have to give the talk yourself. You can just have a good idea and be like, someone should talk about this sometime. So yeah, do that.
In that example, you said that GitHub didn't have the GraphQL for creating issues. So you used a resolver.
So GitHub didn't have the create issue GraphQL API. So actually, all it is I'm using fetch, and basically, where is it? So if I'm authenticated, I'll hit this REST API from GitHub, and then with specified data. So I actually can't do anything about that. I would need GitHub to open up a mutation that adds that functionality.
So on your end, you don't have as part of your own GraphQL API, it's not.
No,
I guess.
Yeah, I wish it worked that way. But basically, you're kind of at the same way of like, if this REST backend didn't have insert API here, like I can't really do anything. So this is basically v3 of GitHub's API. The kind of cool thing is, or not really cool, actually kind of sucks, is so because this GraphQL query doesn't really, so that issues query, it doesn't really know when stuff happens when I'm doing it locally. I need to call this client.resetStore. So this is something I get from Apollo, and basically I'm saying, hey, I know that you'll have new data, go and request it. And so you can do similar things. You can actually do polling, so every 5 seconds refresh this view. I didn't do this. Also, some GraphQL APIs, I haven't looked at this at all, but you can do subscriptions. So basically kind of like long-running polls, like push and pop type stuff, like push to this API and then let the consumer know that something new happened. You can do all that with GraphQL, but I'm not an expert on that stuff, on that particular part, or any of it. Any other questions? Shoot.
Have there been any performance pitfalls and stuff like that that you've run into or
Yeah.
have had to avoid?
Yeah. So in making this demo, it sounds pretty like sunshine and rainbows to say, hey, for every comment, go make this request. And the way I was originally doing it, I wasn't aware of these those like other. So like when I get a post, I'm requesting comments. What I was actually doing is I was automatically grabbing all comments in that initial post resolver instead of using the actual user resolver. And so basically every request of posts was calling the comments API 10 times. So it was just super slow. So basically just be aware of how those resolvers are actually firing. Your API is gonna kind of be slow if you have like 30 resolvers, each grabbing some other particular piece. So if you can kind of structure your REST API to avoid those separate requests, that'll just lead to better performance. Also, I didn't really say this, but obviously like a RESTful backend is kind of like a middleman. If you can, down the road, if you think GraphQL is awesome and you want to get rid of your RESTful backend, if you directly call whatever your RESTful backend is like modifying, be it a MySQL database or MongoDB database or whatever, you can use those resolvers to hit that directly rather than hitting the RESTful endpoint. So if you're running into performance issues, that's probably, depending on how severe they are, that could certainly be an option, is strip that out eventually.
How long has Facebook been doing this?
Since 2012, I believe. So yeah, they started probably on the newsfeed. I actually don't know what they started on, and yeah, they've been using it, I think, in production since 2012, and I think they open sourced it in, I want to say 2015, maybe. So not so like relatively long ago, and as far as client-side technologies go, but yeah, a couple of years. GitHub, Facebook, I think Pinterest. There are a number of like pretty big sites who are using GraphQL in production.
Would you say that Gatsby is a good way to get started with this?
Absolutely. I'm glad you asked that. So Gatsby is how I learned GraphQL. Gatsby taught me the query layer, and Gatsby used that GraphQL. Good time. Chill. CD speakers on that. So yeah, I don't really touch the actual data. Like I'm not really creating data in Gatsby. I'm more like querying it, but Gatsby is what taught me to query with GraphQL, to see this Explorer, and to really kind of understand the things I can do with GraphQL. So obviously, this is speaker sign up running locally. I have it. Oh, I shouldn't. Oh yeah. So this is not hitting Nebraska.js locally. It's hitting just some random repo I picked of my own stuff. And the way Gatsby works is they expose their GraphQL API at this, and then I can get this really good. So I can see basically all the sites that make up the speaker sign up. And without really knowing much about the underlying data, I kind of just fiddled that together. I can see that there's a 404 page. There's all of these proposals. Oh, I didn't even show that. Obviously, you can click on all of these too, and go look at stuff more in depth. But so yeah, Gatsby is what got me to understand and to really appreciate GraphQL and how it actually works. So Gatsby has this concept of source plugins, and so I actually wrote Gatsby source GitHub, and it lets me basically use this query to get all issues, and to like make that queryable via that local site and the production site too. So basically, it'll call GitHub's GraphQL API, make those nodes queryable via Gatsby, and then I can query them to create the pages. So the actual query is basically here. And this is used, it'll work without JavaScript, which is kind of cool. It'll create the static HTML for me. Shoot.
So one thing that I guess I kind of like about Swagger and like say gRPC is that you do have this kind of like intermediate format which serves as a contract between the client and server and what objects are available. So like say for the GitHub API, how did you find out, say, what was available, and so that way you could generate the client?
Yeah.
Also, another really annoying thing that sometimes some of the tools with Swagger have is that you can, auto-generate your client, so you don't have to go through and manually create all the very common actions.
So, sorry, I didn't catch the second question. I'll explain the first one. So GitHub is hosting GraphQL. This is how I learned it. They also have API docs, but this to me is, I guess I'm not the biggest user of Swagger, so you might know more stuff than I do, but this is really what I want. I can go in and look and see all the available queries. I can see the arguments to those queries. So for instance, I can get a GitHub license, I can get GitHub code of conducts, I can get a node, organization, and then repository is actually what I'm using. So I can see here at a glance, the repository has an owner, it has a name, and then I can run this query eventually when I look at all of this, and I get my autocomplete for it, like for free. Oh, I didn't use variables. Name is Nebraska.js and own. Wait, that's wrong. Flip. So this is the exact data I'm getting client side and that speaker sign up. What was the second question?
Well, I guess, so one of the other pieces like Swagger here is being able to, like, say, auto-generate clients so you don't have to handwrite every single common operation. Is there something similar, or do you basically have to kind of handwrite everything at the moment?
Probably. I don't know. I think that kind of probably is kind of what GraphQL is supposed to do, and possibly even some of Apollo's offerings. Basically, they'll like generate the GraphQL API for you given some data, but I don't have a ton of experience in doing it that way. I've always just written it. But that's a good question. I don't know the answer to that. Any other questions? I got you out of here 7 minutes early. So thank you, everyone. Appreciate it.